The other day, my friend, who his wife is the one that does all the embroidery work on my stuff, my hats, my jackets, my towels, everything. You see these things on everything because she sent me a bunch of test pieces when I first was getting these made up, and we were trying them on different towels and blankets and all kinds of stuff. So what ended up happening is I got a logo on like everything. It's silly. It's silly. I can hear him out there telling me right now. He called me in. He goes, "Hey, bro, you know how you make these so they don't cup up like this from the embroidery work?" And I said, "No." And he goes, "Yeah, you got to lay the towel out when it's wet." "Yeah, sorry, I ain't got time for that, so quit cringing." I can hear him telling me in the background right now, in the back of my head. Gentlemen, today we're here to build a beautiful piece of artwork. Now, listen. How do I say this? In the most delicate BBIEs that I can. Let's think about this one for a minute. Okay, I don't like to build things exactly the same every single time, right? I try to add a little flavor, a little panache, a little attitude, a little, just something simple, different. Look, I don't make money from building these boxes. No one really does. You make a little bit, but not a lot. There's way more money to be done on the repair side of things. Hence the reason I'm a repair shop. Okay, there's a lot of guys out there. Well, there's about 24 guys out there that really beat their chest and say, I'm a builder, I build them all the time. Look at me go. And I'm like, hey, do it. I'm not that. I'm here to have fun, make everybody laugh, have a good time, and fix some boxes on the way, or maybe educate some people. That's my brain motivation. So I have to change things up. It's like if you're from the here, we'll put it like this: the beauty of porn. Okay, the self-replicating beauty of porn. That's the best way to put it. It's the best way that my brain is able to come up with. The reason that Larry Flint and Hugh Hefner and all that have money is because us males, we need constant new stimulation. We do. My parents' day was probably the Sears and Roebuck catalog in the underwear section with women. And in my day, it was a little bit harder core, you know, it was the Playboy Penthouse Club, that kind of thing. Magazine. You can't look at the same picture. It's like trying to jerk off to the same picture over and over and over again. Eventually, you're just going to I got to find something else, right? So it's the same thing that we have going on with me in building boxes. I have to do something different. Hence the reason I keep stretching out and I build stuff like the copper mine, or the 99% copper box, or I go build Vader, or I built the copper forge, and then I built there's been so many, and the builds get more and more, like Mr. Jefferson's amplifier, where everything was elevated, and all the coaxes was suspended like power line cables going through a city network, or like the 48 pill that I built for my friend Paul. Not the 48 pill that I built for my friend Paul on this side of the country, my friend that I built for on the east coast side. Look, if I see something I like, I go, that's interesting. And if I see somebody else build something that I like, I go, that's interesting, and I'm going to use it. Okay. And I really expect all of you guys, because I've seen a lot of it, a lot of the stuff, the ideas, the theory that comes off this workbench, that, hey, let's test this and see if we can get it to do a little bit more power. And guess what it does? So then we implement it in every box ever since. I see that trickle down into other people, other builders. I want to be really straightforward on this. Hey, Danny. Everybody make sure to send him the link, by the way. Hey, Danny. Thanks for the idea. I've never done one that's painted. I mean, seriously, thanks for the idea, dude. He's been painting his boards forever, and I'm not going to even pretend like, oh, look, I came up with it. No, I never even thought of doing this. This is one of Danny's things that he does, and it makes him unique and special and different, and it's cool. Started playing with this about 3-4 months ago. The idea came into my mind. It's the kind of paint is what was making me really kind of lean off on doing this. Is if I was to use regular paint, it's not flexible enough to, in my opinion, handle the flexing of the board and vibration and that kind of thing. Well, they make all kinds of different paints, right? So what I settled on using, because I mean, you got like your Rust-Oleums, and you've got your rough stuffs, and you've got your, oh my God, everything, right? I ended up using Duratrax car paint, RC car paint. This kind of stuff. And the reason for that being is it's flexible. This paint's designed to be put on Lexan and designed to be flexed hard under sudden impact and not break. And I thought, wow, you know, that might be a great thing. When the amp gets really cold, I don't have to worry about the paint popping up off the board. It's going to flex. Now, the amount of deflection that would be needed in the board to actually see paint spider crack and peel would be a lot. But for the most part, that's the most flexible paint I could find. And it's also, like I was just on this piece going to show you guys, it's really easy to solder through, just like most paints are. If it is clean copper underneath, it takes just about a second for us to burn through that and make a nice joint. We don't have to pre-scratch the paint. It's a two-part process. First I lay down the base coat. Then I'm going to build the box over it, and then I go ahead and I clear it with a special kind of clear, which will help seal everything, keep all the joints. We're going all out. Now, we're going to build ourselves the Murder Ink box. Murder Ink, all blacked out is what we're going to do. It's going to take a couple days to do because our weather up here is, well, it's December, man. It's shit. It's been raining for 3 days, 2 days now, finally. It started snowing yesterday, finally. Finally. There was a time when I was a child, if the ski resort here in town wasn't open by Thanksgiving, there was a problem. Anyhow, and this isn't even the right solder, I'm going to do this test with Kester 6061, but I'm going to use a different solder that's got a little bit less flux to it than this, so I don't have to worry too much about flux overspatter. So we can just leave this, and the solder just gets pushed out of the way. Nice, perfectly clean, butamus solder joint. And that's not the paint peeling away, that's just a shine reflection of the light from above us. But that's a good solid joint. It flows down, pushes the paint out of the way, and flows underneath. That's why I tested this. I tried about 4 or 5 different kinds of paint, and oddly enough, when I tried this Duratrax RC car paint, it worked out really, really, really well. So I want to say this very clearly once again. Hey, Danny, thank you for the idea. He is the first one that I am aware of, me personally, all the way out here in the middle of nowhere, Idaho, to actually paint the boards and make them a little bit unique and different. So I took his technology, I guess would be the best way to put it, and I played with it chemically and tested it and proved it in my mind, and now we're going to build with it. So let's build ourselves a masterclass box that's murdered out. Why? Because we can. So here's our little hunky heatsink that we've got going on here. Somebody's come back and hit this with some kind of sanding disc. Now there's two schools of thought here. We've got there's guys out there. One of them's a really good friend of mine, and I absolutely respect and love this dude. He's a cool ass mofo. He'll take sandpaper on a sanding disc and go, but it's like 200 grit, okay, or 150 million grit, and he'll hit this space where the transistors make contact with the heatsink. And his theory that he holds to, and his opinion, which it's a beautiful thing in the amp building community. It's a beautiful thing. Everybody's got their own opinion on how things work on certain levels, and I think it's great. I want to test them all. I want to try them all. I want to play with them all. And Ron White said it best, man. We want to see them all. We don't care if they're biker boobies. We don't care if they're mommy boobies. We don't even care if they're like 20-year-old boobies. Get them puppies out. I don't even care if they're the kind that you got to lick and then roll up. You know, like roll up to get back in the bra. I want to see them all. Okay, I want to play with all the different technologies, and I want to look at it. Because this hobby is so and such that there is so many varied opinions on some of the minutia details, and because I'm completely out here in the middle of nowhere, I'm gonna. If this towel was the United States, a majority of your amp builders, this being East Coast and this being West Coast, there was all these different camps that looked like this. This would be like down here in Florida and like that, okay? And then over here on the West Coast, we had, well, you know who that is? That'd be Washington, right? And we're talking DC now, we're not talking AC. And there's a couple like this down here in California, okay? I'm here. I'm all the way out here in a big island of nothingness. So there was no one to go mooch knowledge off of until this guy here in the corner said, hey, when you get tired of pulling your wiener all by yourself, why don't you just come hang out with me and get a little bit more knowledge? And that in turn led to more people, that led into more knowledge, that led into more stuff, that led into more stuff, that led into today. I'm proud to say that I am not ashamed of the fact that I am a Quasimodo production of all of these different camps and different builders, because I look at it all. Some guys will go and lap, what I was getting at is some of these guys will go and they'll lap this out with sandpaper. Well, and the theory behind that is that it gives an egress path for the dielectric material, the thermal lapping, thermal compound that we're going to put, not dielectric material, it gives an egress point for the thermal grease that we're going to put to help take up the micro gap between the heat sink and the base of the transistor. Okay, because there's nothing sits perfectly flat. There's no such thing as perfectly flat. You get to a point where you get flat enough to where you take the two pieces of metal together and you push them together, and then you get a thing called cold welding, and then it's an expansion kind of weld, and then you've got. My goal is I like to have flat. I look at the computer industry, I look at the heat transfer industry. I've read, books and frickin' papers that are 10,000 pages thick and they're peer reviewed, and I take that data into play, and then I sit here and I test it. I actually built the box, heat the thing up, do it with the 200 grit sandpaper, build the box around the heatsink, strip the heatsink off, go out and polish the heatsink down flat, reattach the same transistors and monitor the heat. Smooth lapping works best. It does. It allows us to dramatically increase the surface contact area. But in the same breath, if you use too much thermal compound on the base of your transistors, you have a thing called hydraulic cupping, where you go and put the transistor down, and because we have this poorly 1960s based mounting procedure that we're still using here 40, 50, 60 years later, where we're attaching the transistors out on the edge of the ear, and not applying any physical pressure down. Not that we could ever do that because the lid's not structurally developed for that, but a lot of the LD MOS transistors we can. Some of them we can. Some we can. When you screw down on the edges, there's not enough physical pressure in the middle, universally even, that is asserted into the middle of the transistor that allows us to have an equal amount of migration. That, and when you put the board down, sometimes there can be a seal that forms around between the board, the heat sink, with the thermal compound, and so the thermal compound's got no place to go, and we end up bending the ears of the transistor down, and the bottom of the transistor's cupped. Thermal cupping. Thermal compound cupping is what I call hydraulic cupping. Because the grease is a non-compressible fluid, per se, if you want to call it fluid, semi-solid. It causes the bottom of the transistor to scooch. So I go with very small amount of thermal compound, but I want a very clean, non-oxidized surface. So how do we get there? I had the camera set up perfectly for this shot, and then I went, wait a minute, how do I get to that side of the room? I got so much stuff in here, you guys, I cannot physically go from one side of the room to the other. Me personally, I like to use I'll start out with a red abrasive disc, then I'm going to transfer over and we're going to go to a blue abrasive disc, which is about 250 grit, 300 grit-ish, and then I'll come back and I'll hand lap this. And I like to use a compound that is specifically made for copper lapping, because it's softer than the aluminum, so therefore we're going to have even less. I want this to be almost like a mirror finish when I'm done. So all we've really done is we've polished off all the oxide that's on the aluminum. So you've got your oxidization that happens from the extrusion and the extrusion process, and then just pure oxygen to blah, 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 blah barrier. The other thing is, now that we have a uniformed amount of depth of surface scratch, so now I know what I can go and I can correct too. Really simple, super fast, right? So we'll get rid of this disc, and there's a billion ways to do this. Don't think that there's not, and I'm not saying this is the best way by any means. I'm saying I want you all, you gentlemen out there in the video land, to not be afraid to experiment. Do not be afraid to test different things. Get yourself the right equipment. Like, I went out and I bought myself a FLIR. It was like a lot of money at the time. I remember my first FLIR, I spent like $400 for it or whatever, $500 for it. And that was a huge get. I remember going, good God, can I really afford this? Well, it's paid off in droves in more ways than just, hey, let's test the heating dissipation of our transistors, right? So now we'll go to a finer grit. And the only place on this heat sink that I am even remotely giving two shits about is where the transistors are going to go. I could have sea-encrusted fucking ball barnacles on this thing and I wouldn't care, okay? The only thing I care about is the surface contact point for the transistor. Of course, I do care about that. I want to make sure that the fins are clean and open, that there's no burrs. Sometimes that when you get these the heat sinks or you cut them, there's a whole bunch of burrs that hang down off of each fin. That causes air restriction. I just come along with a little handheld DA and just knock those off real quick. It just takes a second. In the old days, before I had any fancy dancy tools, which I still don't really have any fancy dancy tools, but I got tools, I'd take a razor blade and I'd cut each one of these fins by hand to maximize the amount of performance. So now let's go ahead and let's wipe this down. We don't want to use anything moisture based, so like you want to avoid spraying anything moisture on here, like window cleaner or anything like that. Just wipe this down. We're going to tape this off a little bit to help contain the polishing compound, and we're going to come back, we're going to hand lap this. So let's reset up the camera and move to the other side of the shop yet again. Don't use a paper towel. I like microfiber cloth. It has a tendency not to. The reason I say don't use paper towels is kind of a hard construct, and we want to try and keep our contact with this as soft as possible. I say experiment. I say try everything. If you're into building, once you get your first 4-pill built, so I watched several people in this game that they showed up here knowing very little. Then they went off and they took a couple of the ideas that were planted in their brain by me and by other people, because there's so much knowledge out there to be had. Now they're off building on their own, and it's really neat because it's self-taught knowledge. This really is not that complex of stuff to make. It's not. It's like RF chemistry lab, backyard technologies 101. Do you absolutely need to lap every heat sink that you come across? No. There's a lot of guys that won't even bother doing this. They'll bolt the transistors right up to the mill scale on the heat sink. They don't care, and it's okay. That's okay. I mean, that's the way they want to build. That's the way they want to build. But what I'm getting at is, if you want to experiment, don't hesitate. Go play. Just don't do it on other people's money, and don't do it on other people's products, is what that means. So go play, have fun, build yourself a test piece. And this is just copper polish. That's all this is. This is Wright's copper cream that I'm using here. Go experiment, go learn. And if you, like this situation here, if you see something you like, give credit to the person that gave you the idea. Give credit to the person that gives you the ideas. Give credit to the people that teach you, okay? Once again, I'm out here in the land of by myself. Not, oh, I get to go learn from Dave, or oh, I get to go learn from Tony, or I learned from Lynn. I started out looking on the inside of an amplifier when I was a kid going, I can make that work better, is what I thought to myself. If I just do a couple little changes, I can make that work better. And that same mentality carried on to being an adult and looking at stuff that was being built and saying to myself, I can make that better. I can do that better than what I'm seeing here. Well, then I started to build my own boxes. And the first ones looked like crap. They absolutely looked like dog dirt. Okay, don't fool yourself. Don't fool yourself. They looked horrible. But from the first one, I went, okay, let's build another one. So I started out and I built the next one. And a lot of the mistakes that I made in the next one, I deleted. A lot of the mistakes I made in the first one, I deleted in the next one. And so on, and so on, and so on, and so on. And then you get a couple thousand boxes in. Your wealth of knowledge, your planning of the project, like where to start, where's the middle, where's the end. Okay? That all changes. And you start to think about things, and then your mind starts to grow a little bit. Well, I had that advantage thoroughly because I had no one saying, oh, I've already tested that. You're doing it wrong. You're doing it wrong. I didn't have that problem. I was free of that. Hence the reason, just living out here all by myself, dealing with this, having this as a goal, allowed me to overcome that. And once again, it's like looking at porn. It's like looking at porn. Got to have new stimulation. Otherwise, you're going to get bored. I couldn't sit out here and build the same thing over and 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 over again. I couldn't do it. I go nuts. I'm like, wait a minute. I quit my 9 to 5 so I could have the freedom to do whatever I want and go pursue my passions that I want. Why would I want to do the same thing over and over and over again? It makes me like a Memorex machine or a photocopier. And really the only way that you're going to learn this circuit, build it, break it, build it, break it, build it, break it, change some things. Build it, break it, change some more shit. Just saying. Just saying. That's good enough for the girls I go with. Mill scale's off, it's relatively flat for the most part. Is it scraped precision milled flat? No. There's some machinists out there that are like, whoa, you coulda. There's a lot of different things I could have done. But this is flat enough. This will allow me to get the most efficient heat transfer from the base of the transistor to the heatsink. And I've covered this in many, 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 many YouTube videos. And I feel like I have to repeat myself often and frequently, because I have to treat every video like you, the viewer, is watching it for the first time. Otherwise, what happens is somebody goes, well, why didn't you do this? Well, I covered that in this other video. And then the immediate automated response is, where is that? I can't find that link. So I do the same thing that they could have done, and I just go do a Google search, but it's never dawned on them. Where, if I sit here as I'm doing the assembly process and simply talk you guys through the steps each time, I save myself that legwork, and maybe, just maybe, and I mean this in the best sense, just maybe, there's somebody out there. I don't know who you are. I don't know where you come from. I don't care. But maybe, just maybe, I get to inspire the guy that's eventually going to replace me in this business. And I think that would be freaking cool. To give birth to another amp builder into this community, in my opinion, is the best form of flattery. Now, do other amp builders look at it like that? No. A lot of other amp builders won't tell you how anything works because they see you as potential competition to their business model. Well, I'm here to tell you, being open and sharing information and talking about everything you're doing in minute, fine detail has served my business model well. And I've seen a lot of other people grow from it. So don't be afraid to play. Definitely don't be afraid to share knowledge. And I'm not going to lie. I turn down more work every day, literally every day, than 10 people combined can do. I am working on equipment that is here from last September. Not this year, not 2021, but from 2020. Because I got so much work so fast. When I got it all, I went out there in public and I said, hey, I've got more work than I can possibly do. Do you guys want this equipment back? And all I got was crickets. So it's not like anybody gets to bitch. If you want your equipment back that you've had sitting up here for a year waiting for me to work on it, call me. I'll gladly send it back and you're not going to get any grief from me at all. Hell, I'll even, instead of shipping it to you, I'll ship it to whoever other amp builder or guy that you got working on it, want to have work on it. I don't care. I have probably at least 10 people a day call me with some kind of project wanting me to work on their equipment. And I have not taken on any new work. September, I think 22 of 2020. I got a lot of equipment here. I probably still got 400 plus pieces worth of other people's equipment here from the initial like almost 800 pieces that showed up over a year ago. So sharing knowledge, being kind, not belittling others, and teaching has served me unbelievably well. So just keep that in mind. And hopefully, one of these videos will inspire the next generation to pick up the mantle and maybe replace me in the future. Just saying, it's a goal. I think it's a healthy one. Okay, so I punched a hole here, 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 and here, and here, which we're going to need to run wires around, about, and under and through. And so that meant I had to do some quick touch-up paint. So now that we have that done, let's put some transistors in it. Okay, so yeah, those are Toshibas that are in there. Look at that, isn't that pretty? Okay, so pills are down. Now we're going to put our 10 ohm resistor here, 2 here, 1 there, 1 there, and then 1 there, and then we're going to put our 120 puff caps there. So we got our 10 ohmers in, we got our 120 caps in, we got our power distribution in, we got our power distribution bus. That bar in the back is a bus bar. Got all that in. So now, come on, get there, we go. So now what we're gonna do is we're gonna put our output transformers in. We're gonna put, from the transformer side, 3 turns of wire, or from the transistor side, 3 turns of wire, which really works out to be about 1.5 wraps. We're gonna tie our ground in here and our other ground in here. And then we'll do the same thing on the input transformers. Same number of turns, tie our ground here, tie our ground here. And we do that so that the input transformer and output transformers aren't out of phase. We're going to put about 1200 puff worth of capacitance on the output transformer and a little bit more on the input transformer because, well, as you all know, mine are mine and they require a little bit different sauce. So with that note, so hustling right along here to the future generation that might be watching this, I'm going to give you the most valuable tip you're ever going to receive from me. Don't ever sacrifice quantity for quality, ever. And the next thing is you have 2 kinds of builders in this world. At least when it comes to this, well, many other products. Is you got the guys that can copy it, and then you have the guys that actually understand how it works, and they can modify it to their own needs. The biggest thing that you're ever going to need to know how to do is going to have to be understand how to calculate a device's input and output impedance. That is the most key thing to actually understand anything. Now, 2879, it's got one thing. The MOSFET components, which inevitably will take over the market, they're a completely different thing. And understanding how to calculate and service the input and output needs of a device, that basically unlocks the keys to the whole cabinet. Once you figure that out and understand how to do that, you can build anything. Anything. And understanding the minutia in making that work. The front panels of my input transformers, for an example, we're using this as an example, because the beads are spaced out for better cooling, there's more surface area to the panel area on the front, so therefore we have to use a different capacitor here to make the transformer think or load, simulate or emulate or load the transformer in a different way so that it can be resonant with the input impedance of the device. The same thing with the output transformers. The output impedance is calculated to be X, let's say, and for the surface area increase, because the transformer is a little bit taller, and because I use heavier wire, that way I can get better core saturation, which means more output power, less resistance to the component's output, we have to add more capacitance on the output transformer. Okay? Understanding how to manipulate this circuit allows you to build it any way you want. That way you're not stuck looking at the same picture over and over and over again. It makes masturbation a lot easier, basic point. Okay, so the next thing that we put together now is we'll put our load cell resistors for our bias. We're going to build those up, we'll install those, and then we're going to run some wires. We'll probably put our relay in here and our bias relay in here, and we'll get this thing pre-wired. So when we come back, we're going to have the resistors on here, and then we're going to talk about the biasing circuit. So on that note, we're working on the bias over here, but I had to jump in here real quick because this is going to be our cabinet. And it's time for us to start talking about other stuff along with the actual construction. Because it's so cold, the painting's going to take a couple days on this. So we are going to completely paint this thing inside and out. We're going to do a completely murdered finish on this. And I think that we're going to do a hammered gloss black on the outside, and then we're going to do gloss black on the inside, because we're going to murder this thing out. But I now get to go spend next 45 minutes of my day with 220 grit plus sandpaper, and I got to scuff the crap off this clear. Otherwise the paint's never going to stick. It's going to get 2 coats of primer, sanded in between, course, and wipe down, and then we're going to come back and we're going to put a hammer finish on this. So I'm going to add this to our list of chores for this. Okay, I'm going to go make a mess. Yeah, so we got our bias resistors in place, and we got our bias relay in, and we got our transmit receive relay in. And now all I got to do is preload this and load this with wire and put our coax in, all that kind of stuff. So we're going to go ahead and we're going to move on to that step. It's December and I live in the Northwest. If you didn't know, I live in Idaho. It's in the name of the business. Painting in this weather is a pain in the ass, let me tell you. This cabinet, I had to sand it completely, wipe the whole thing down with alcohol, which is just normal prep. Then I laid down a layer of primer. That was after I preheated the cabinet. So I preheat the cabinet, get it up to the whole cabinet up to about 100, maybe 90 degrees, all the metal. Lay down a layer of primer, let that initially set up, bring it back inside the shop, heat the thing back up to about 80 degrees or so, let that become hard. Take it back outside, sand it again, okay, real light, really, really light. Heat the whole cabinet back up, shoot it with another layer of primer, bring it back in here, heat it up, let it get hard again, and then go outside after I sand it, wipe it down again for the 3rd time, and then go ahead and now I've shot the inside of this. So I've painted the entire inside of this cabinet with a matte black finish, okay? This is coat number 1. So I got to warm the cabinet up, let the paint solidify, and I'm just painting the inside and the out edges and that kind of stuff. Because where the hammer finish is at, I got to be very, very careful how I put the hammer finish on. I can't just like, I got to put the hammer finish in very strategic places. Otherwise, when the lid goes to close, I'm not going to ever get it to seal, and the paint's going to get in the way. So like after this gets hard, then I got to lay the cabinet down, lay down a line of painter's tape around the edges on the bottom, then flip that in reverse, and then cover up the sides and the top with painter's tape so I can shoot the hammer finish on. So when we put the lid on, all the paint lines match up because the hammer finish is a lot thicker than regular paint. Here we got that. And I got to do it right in the middle of the day, like 1 or 2 o'clock in the afternoon during the peak heat of the day of 40-something degrees. So I can heat the cabinet up with all the paint on it, and hopefully none of the paint tapes, peels, splits, or comes apart. Zip it outside, spray it down to schmoo, let it basically set for a little bit, and then bring it back in and then maintain its heat until the hammer finish finishes. Painting is fun. It's just as much fun as the rest of this. It's just all part of the process to me. So what I'm saying is that I can build this I'm on day 2 of this. I could build this out plainly in like, an entire day. Well, maybe a day and a half at the level I like to build. Because when I mean, every one of these wires is the same length. Everything is measured. Like the caps, they're within 1% of each other. Even the disc capacitors I put in here, I measure those and make those 1% or less, like dead on. Everything has to be the same, and that all takes time. Set up for each one of those tests, test the components, move them into a pile, put them into a group, and then actually go and put them into application. Same thing with the 10 ohm resistors. Let's say you order 200 of them cocksuckers. You're going to get ones that are 9.8, 9.7, 9.6, 9.2, 10, 11, 11.1, 11.2. They're a 5% component, and you got to go through and match up 4 of those that are all within 1% or less of tolerance. The same thing with the 120 puff capacitors at this level. Okay. I don't make a big deal of it in every one of the videos, but if it says masterclass on it, that means I've literally taken the time to measure every single part and put its tolerances within 1% or less of each other. A lot of guys will just take the bag of parts, dump it on there, cut the thing, and throw them in the good 5% close enough. Does it really help with power, like making power? Certain caps, yes. Other caps, no. It doesn't make that big of a difference. But still, if you're going to do it on 1 or 2 components, might as well do it on the rest. The other thing you got to do is like these relays are not made in the United States. They're just not. They're made in China. Okay, we don't manufacture a lot of shit here in the United States anymore. So every one of these relays, because I've had a couple of them fail me, I have to pull the case off of it, get out the relay contact file that I've got, and go in here and file and test every single connection on the inside of the relay, open and close, make sure I got good contact. Because we don't know where these come from. They could be coming from a dirt floor hut in China. I'm just saying. All of this stuff adds up to more and more and more and more headache, right? So, needless to say, here it is. What is it in the afternoon now? It's 3:30 in the afternoon, and I started on this at 8 o'clock this morning. The first time you see me snap my fingers was at 8 o'clock this morning. I'm not going to finish this until the day after tomorrow. There's a reason that I have to ask so much more for the box. Not just the transistors, but it's the overall construction. Imagine if we take this times, let's say, a 48 pill. Yep. Okay, let's load this with wire. I'm going to set this aside and let this thoroughly set up, and we'll go from there. Okay, so the cabinet has got the last coat of paint on it, and it's sitting here drying on the inside. This has taken so much longer than I thought it would. I'm still kind of figuring in my head how I want to go about doing the face of this. Like, I got to put labels on it. And hammer finish is textured, and labels don't like that. So we're going to let this dry and get thoroughly hard overnight. And what I'll probably do is I'll print off an exact, like I'll put Master Builder class, whatever, down here at the bottom. Made in America, blah, 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 blah. Get all of those spots pre-labeled with, clear label. Put all of that on here. So then I can go and I can shoot the front and the back with the labels on it. Shoot it with the paint. Let that semi-set up, and then maybe be able to peel those off with a razor knife. And I can have perfectly flat paint texture underneath, so I can come back with the actual labels and put them on. We'll see how that goes. But the painting things today, because it's been so cold and it's so wet out, I'm not gonna lie, has been a little bit of a challenge today. So I'm grateful that I got this far, but this is the end of my day as far as this stuff is concerned. Tomorrow this paint cabinet. I'm going to put the coax in, put the output tuning, input tuning in it, get the key-in circuit built up, which is going to attach over here. The sideband delay is ready to go in. That's what's sitting over here. These are our sideband chokes. We'll get those installed after we get the amp actually in the cabinet. But for right now, we're waiting on paint to dry. So, on that note, I'll see you guys tomorrow. Okay, so inside of this is painted, primed, scuffed, and loved, and rescuffed, and then primed, and then, yeah. So, I'm going to heat this cabinet first. I'll preheat the lid first. Paint this first and see what we got for texture. Because I've got to put another coat of paint on this. Either it be high gloss black, or I'm going to have to do the hammer finish on it. My goal is to make it all hammer finish, but still physically fit together in a good way, right? So, that's just primer that are on these things right now. So we're going to use this as our test platform. We're going to go shoot this with the hammer finish on it here in a couple minutes. We're going to let it set up for a little bit this afternoon, and then I'm going to do a tape test to it, and we're going to see if the label will actually stick to this or not. If not, we're going to go with plan B. The more I think about this, me trying to put the labels on here and then do the hammer finish, which is relatively thick, and then pull those back off again. I don't know. We're going to play with it. Let's preheat this. I'm going to paint this. Let's test it. Ready? So keeping this relatively warm is the key to getting the finish to come out hammered. So capitalizing on that, I'm not heating the face of this up too much. And the back of it, pretty cool. The lid turned out beautiful. Beautiful. So now all I got to do is sit back and let this sit up for a couple hours, and then I can go ahead and I can mount the board in here and we can finish this out. But I'm here to tell you, painting this stuff up here in the cold, it sucks. It sucks. Okay, so this is all wired up. Now this is a time off timer, and I had to go with a programmable micro timer like this instead of using like a big Omron or something you guys have all seen me use in the past with like a physical mechanical variable resistor on it that allowed us to adjust the time because of real estate issues. I wanted to add this to this amp. This is just a fun little option that I've been kicking around in the back of my head. And what this is going to give us the ability to do is when we turn the amp off, the fan's going to stay running for 5 minutes, and then it'll auto shut off. And that's to guarantee that the amp is cool. Okay, we don't ever have to worry about, oh, I got to let it run for a minute or two. Whoever ends up owning this, they can flip the remote switch off, click, and forget about the amp. It's going to self-cool itself down, and within 5 minutes it'll get itself completely cool and shut itself off automatically. It's not run by heat, it's not run by anything other than time. And right now we've got the threshold set for 5 minutes. At the end of this video, after the credits roll, and at the very end, I'm going to add how to program this little timer, just in case all of you guys out there in the amp world want to know how to use this thing. It is a pain in the ass. It took hours yesterday to figure this out, figure out the interface, get the programming set the way I wanted it, and then figure out how to set it so I can use just a single trigger wire with this relay to make it so that the remote lead or the faceplate switch will activate and make this timer work without using a double pole single throw double pole relay. It's a little bit of work. Now, from this angle, it looks like your airflow is really restricted, but it is not. Plenty of air is going to be able to weak out around that thing. Really, this is not that big of a deal. This thing's never going to get that hot anyhow. It's just not. It's not going to get hot enough to do any damage, but this thing requires constant hot, constant ground, and a sense wire, and then it's got an output. So 4 wires and a little bit of Wi-Fi programming. So if you're interested in this unit, it's at the very end of the video after this segment's done. So on that note, we've also got the cabinet completely painted. This is all hammer finished. Hammer finished. Hammer finished. And so is the lid. Now this is a biatch to get painted in the winter, but we got her done. So now we're going to take this, flip it over, slide it in here. So on that note, all right, let's see what our pass-through tune looks like, you guys. Turn on the old venerable KC901 here. And now what we're measuring is the radio's ability to talk through the amplifier. So we've got at about 27.144 megahertz at a 1.5. And that's the RF going through, coming through all the connections in the relay and going back out to the 10,000 watt dummy load. So y'all know the solution to this. What's that say? Think. Okay, so I know what cap I need to add. Let's go ahead, let's add that cap, and we'll reshoot this. All right, so we added this capacitor here to help compensate for the input inductor bump, as you guys know. Those of you that watch my videos, this is a normal thing. See how we did. Poof. Oh my God, look at that. 1.008. Wow, that's good. That's screaming. Okay, well, we got to finish the RF path inside the amp. Input and output tune, and put power wire in it. And my biggest question, honestly, is that time on timer going to work the way we think it should? And like that, we're 99% done. So, switches are in the off position. Let's go over here and let's get you guys a form of measurement. So as always, where are we? 1,000 watt slug and peak. 1,000 in average. 5 watt slug and reverse back from the bird. 10,000 watt dummy load. We're going to hit it with the Striker derail 955. About 135 watts, right? 135 watts in. Well over 1,000 watts peak out. Put that on 2X. So now, when this needle goes fully to the right, it's 2,000 watts. So that big hash mark right there. So we can get a little bit better pointing device here. That big hash mark right there, between the 10 and the 15 is 1,000 watts. So let's see here. All right, 13 and some change, 12 and some change. It's working just the way it should. Let's go up here. Let's go look at the front of the radio. See if I can catch this just in time. Nope, I'm gonna have to back this out. Hello, 11111, ho. It's because we're reaching maximum drive. Radio's happy, I'm happy, bird meter's happy. Hello, 1-1. Hello, audio, 1 2 1 2. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. Hello, 1 water reflag. 150 going in. Pretty good. Audio. Okay, it's more impressive when we look at it in 1x, in my opinion. Yo, we be jamming. Run to the corner. Okay, we've tested it. Now we've got one other circuit that I want to show you guys. One other little thing that I want to play with. Let's show it to you right now. That paint came out not too bad. And everything stuck easily. This has got way more hammer finish on the lid, but it's same finish on the face and the back. But it came out not half bad. I am content. Well, the last circuit I got to check is this. The fan is on. The fan is doing fan things. Laying it in the corner pretty good. I'm done with this. So, now, this is a time thing. Let's say we've been talking on this thing for a couple hours. On, off, on, off, on, off. Well, most amps you gotta wait for a couple minutes for them to cool off and then you can shut them off. Not on this thing. Not on this thing. This one, we flick the switch off and it's gonna count down. Now, in about 5 minutes, give or take, that fan is going to shut off. Now, to save you guys the heartache of having to sit here and not listening to me monologue or tell you a story about the time that I was a kid, and the neighbor girl, after she got done eating French fries, she let me make out with her and kind of put me off with French fries for a hot minute. We're going to skip over that scory, and we're going to go boop and hit the fast forward button. Ready? Go. Well, if my calculations are correct, when this bitch hits 5 minutes, this is going to be like 4 minutes and 55 seconds, we're going to see some cool shit. Everything's off. And no, this isn't anything new. This technology's been around forever, but the Wi-Fi programmable freaking time off timer, that's new. But a time off timer in a box, not new. Getting close. And it's a PDM too. So I've got it set up so it ramps off slowly. Perfect. Well, something new, built with old school technology. I mean, it's an old idea with some new tech behind it. And no, this is black hammer finish, even though it looks brown on video for some weird reason. It's like a metal flake black. It's really pretty. Well, gentlemen, the Murdered Ink amp is all done. And I think we're going to ask probably $1,500 for this. With the Toshibas in it, the time that's in it. $1,500 is fair. I really do think it's fair, so. Well, you guys that have tuned in and watched all the way here to the very end, I want to say thank you. Thanks for spending this much time with me and giving so much of your life to me. I appreciate it. If you get a chance, go to patreon.com and just come help the channel out just a little bit. I'd appreciate any support we can get from anybody. We're clicking right along, and this is what I'm doing full time. Next major announcement is I'm going to build for my friend Frank, aka Mr. Black. Me and one of his other friends, we've decided to get together and we're going to build him an honorary amp. And that's going to take up the rest of this next week. It's going to be a 2-part mini-series, probably multiple hours per video. So those guys that like the long videos, you're going to have long porn. Lots and lots and lots of it coming up here in this next month, the rest of this month. So on that note, gentlemen, it's a big project. For me, it's a fairly large project. It's not all that huge of power, but it's enough. And I think it's going to all be good things. So, you guys know the drill. You want this? Call that number. Shoot me a text. I'm out of here. I thank God for every one of you guys. Please, if there's anything I can do to help you, you got a question, something, give me a call. I'll do what I can to help. I'll see you, gentlemen. Click, click. Well, gentlemen, let me introduce you to the www.bit.ly/timer20. This is the 10 amp system. You can buy this off of Amazon. You can buy this off of eBay. I'm sure this dude's sold 1 million of these units, and they promptly got thrown in the F-it bucket because the people that he sold them to could not understand his non-clear instructions on how to set this thing up. We're going to cover some of the things that I've figured out with this timer. I'm using this in a time-off timer configuration because it is sold as a time-off timer. Well, it is, but the instructions do not cover this. Now, the guy that created this thing and gives the instructions on YouTube is an engineer, speaks like an engineer, thinks like an engineer, and I'm sure it makes perfect sense to him and everybody else that is engineer fluent. Okay. To us high-functioning retards that are just trying to simply make it so our fan stays on after we flip off a switch, your instructions are the worst, shittiest written things I've ever written in my life. They leave a lot of things to be explained, and they don't make any flipping sense. When really it's the simplest thing in the world to get set up, now that I understand how to use this timer. Nowhere in your instructions does it say that the green wire can be used as a switch hot as your sense wire. All they talk about is the blue wire as your trigger for the timer. How the timer works is that you're going to give it a ground and your positive current. It's from 0 to 24 volts, I do believe. Your load is going to come out on your yellow wire. So the ground wires float, they're tied together. This is the ground lead for the timer. This is the ground lead for the fan. In this application, we're going to use a 120 millimeter fan. The voltmeter is here to show us that we have power coming out. Okay, now you can go and you can jump down the rabbit hole of trying to program this thing with switches and get lost, or you can spend $1 more and get the one that's got a Wi-Fi encoder in it. So how we get into the Wi-Fi programming of this thing is simple. Not simple. If you try to follow the instructions that are provided, either it be through the YouTube video, and the only place I was actually able to find the right web address to get into this was on the paperwork. But only on the outdated form of the paperwork. On the new updated form of the paperwork, they link a YouTube video and the guy gives the wrong web address. So if you're trying to follow his instructions on the YouTube video, forget it. You're never going to get logged into it. The address that he gives is 192.162.4.1. The actual right web address, because he's not willing to fact check his own shit, is 192.168.4.1. Okay? I'll cover that here in a minute. Anyhow, how we actually get into this thing, out, this orange wire we're going to completely abandon. We're not going to do anything with it. The blue wire, we're not going to do anything with it either. This doesn't do shit. This blue wire doesn't do shit unless you're doing a time-off pulse mode, or if you're wanting this to run an LED modulator system. So forget this. As a time-on timer, time-off timer, this is not your trigger wire, it's your green wire. We've got this configured in 12 volt high. So the trigger is going to be activated with 12 volts being applied to the green wire. Positive, 12 volt positive. Okay, so to activate the Wi-Fi mode, which you guys are going to have to know how to do, we're going to take the white wire and tie it to the ground. Then we're going to simply attach 12 volts to the timer, and the blue light's going to start blinking. Once you've got your Wi-Fi enabled on the timer, you're going to come over and you're going to connect to timeshop.wifi 521, okay? Once you're connected to that, you're going to come over here to the search window. Actually, up here at the bar is where you want to type this in. And what you're going to type in is 192.168.4.1. Oh, pardon me. .1. Enter. And that's going to bring us to our programmer window. It's just like going into your Wi-Fi router. So from here, you got your timer configuration, which is the window we're going to go into. Firmware update, do not touch this. Power on. And power off. Now what just happened is the fan turned on, turned off, and we did that via Wi-Fi. Okay? But what we're going to do is go into timer configuration. To use this in the time-off timer configuration, we're going to go to mode 12, so function 12. You're going to set your timer on, first time 1, that's all you're going to worry about is T1. You're going to set this at 5. T2, we're going to set this at 5. We're going to set our analog trigger. We're going to set this not digital, but analog. We're going to set it to 2, and then you're going to set your low voltage at 0 and your high voltage at 10. So anything over 10 volts, it will trigger this thing and say, okay, it's time for you to do your job, and it'll start counting down. Now, this here is a positive output, or we can switch it for a negative output. So either we can switch on hot or we can switch on ground. That's set up from this window. And do we want it to ramp in gradual, or do we want it full on? So we want it full on so we don't have that box clicked, and we don't want to have it reversed in function. Nowhere in the instructions is it showing this to us. Now, for the sake of demonstration purposes, we're going to set this up for 10 seconds. So we'll zero out our timer 1 and timer 2 so they're not in conflict with each other, causing the unit just to turn on and stay running, which took forever for me to figure that out as well, because nowhere in the instructions is that stated. Okay, so made some changes. Now we're going to tell it to save, and it is now written to the timer. Let's go over here and let's go play. have our positive 12 volt lead attached. Everything's just exactly the way it was. What we're going to do now is we're going to disconnect our white wire and we're going to pull off the red wire. We're going to count for a couple seconds and let the little capacitor in here discharge. Please note the blue Wi-Fi indicator light is off. The timer is now on and active. Okay? Once we lift the 12 volt off this green wire, fan turns on. Once we reapply the 12 volt to the trigger wire, fan turns off. So for all of you guys that are out there trying to struggle through the most painfully written, shittily described instructions on the face of this earth, for this thing, now, this is a relatively cheap timer versus, let's say, I don't know, an Omron or something like this. Some of these are 50 to 100 bucks. This is a time off timer that goes to 60 seconds an interval. Okay, if you were to buy this thing brand new, this is a much cheaper possible applicable process for you. This thing does 25 different functions. It's primarily geared around running lights. Okay, very low amp rating, also very low amp rating, but idiot free. The hardest part is trying to figure out how to wire the socket, which is the same thing. Depending on your coil, you're going to have 110 volts in it. Usually pulled to ground signal wire. So, fan on, 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010. Off. All right. Well, I'm going to put this out there in the digital ether for everybody to consume, eat up, and enjoy. And if in some way this helps somebody, give me a thumbs up. My YouTube channel is most likely not going to apply to your brain bag of knowledge because I do antique radio equipment. So therefore, don't bother subscribing. Just use this information. Go over to this dude's webpage and tell him to write instructions that are in English that normal human beings can use. I'm BBI. I'll see you. Bye.